Hello, prospective graduate students. Thank you very much for your interest in our BAE programs. This is Dr. Lingjuan, working in air quality and animal production system engineering. I would like to use this opportunity to introduce you our research projects. Actually, more specifically, we have three research directions that involves air quality engineering associated with air emissions from animal production systems. More specifically, we have one ongoing project funded by the NSF to investigate feed transport and transformation of ammonia emission from the animal housing. And also we have interest in animal housing environmental control. More specifically, we would like to improve our control systems not only based on the sensors measurements, but also incorporate animal behavior data. That's one of the research directions we would like to go. And also we're interested in investigating animal stresses to improve animal welfare through the ventilation controls and environmental engineering principles. Anyway, so as you can imagine, three of the research directions involves multidisciplinary collaboration. We collaborate with poultry science folks, animal science folks. We also collaborate with professors in sensors and controls. A little bit of background, in North Carolina, we are big in swine and poultry production. We have over 6,000 of the farms, production farms, swine and poultry farms across the state. As you can imagine, those can, concentrated production systems can generate significant air emissions, not only have an impact on in-house, but also have impact on the surrounding area and our ecosystem. So our first direction in terms of air quality engineering, we want to investigate the impact of the ammonia emission and also magnitude emission, and also once emitted, how the mechanism for their feed and transport, and through the deposition and through the chemical transformation, how would that impact on the air, soil, and water? And one particular interest we have is how would that impact on the ambient air quality, the formation of the inorganic particulate matter, which is through the acidic ammonia and base ammonia and acidic gases from other sources. They react from the salt, which is the Criteria Pollutant and the Clean Air Act. So we have a site to set up, and it's 2 hours away from the campus, to monitor the ammonia and ammonia concentration at the 3 heights to quantify the deposition. And also we have, that's a 7 meters scaffolds. We also have a 10-meter towers to quantify the deposition of the gaseous phase ammonia. Those are the production houses. We also have a range and chicken farm here, and also the manure storage place. And this whole facility emits different sources. We try to quantify those impact on the surrounding areas. We have a continuous monitoring sensors to monitor the gas, to monitor particulate matter concentration as well. And for the, as you can see, there's a continuous monitoring and also the sampling at the 3 heights, along with 3D anemometers to measure the atmospherical conditions, anyway, more specifically wind speed and wind direction. And also this is a particle phase monitoring. And also for the soil, we take soil samples to examine the microbial community and also the diversity of the soil as impacted by the ammonia deposition. For the heat stress, for the environmental control, we have a USDA funded project using our our own facility to test the heat stress of the heavy broiler. When we talk about heavy broiler, which means the broiler grows to more than 10 pounds, and those broilers are quite vulnerable to the heat stress under the hot and humid conditions. So this project is trying to not only to develop an engineering solution, but also to obtain the fundamental data of the heat and moisture production from heavy broiler. In the literature, our data is quite out of date. only for the smaller broilers. Anyway, so that's one of the objectives. And this is our facility. We have 6 chambers built on the Lake Whaler farm. There's a university-owned facility, is 5 to 6 miles away from the campus. It's quite convenient. And we have a control system, automatic control system, control the blower to apply the ventilation rate for the treatment. Anyway, we have the birds in the chambers to raise up from the 28 days to all the way to 61 days. You can see the chickens grow so fast. And because of that, when they grow to the market weight, they are quite vulnerable to the heat stress. And we also have fun working with poultry science folks to examine. You can see the welfare parameters, the bones, the skins, and also we have a camera to record their behavior in response to the heat stress. And we also examine the meat quality by the poultry science professor led by the Dr. Oviedo, and it is fun. And we have a big group there and run the heat stress for the three years already. And both projects, air quality project and heat stress project, we have quite a bit of data already obtained. We can we can have a graduate student be trained on the projects, those 2 projects. And last but not least, I would like to let you know that in the department, we also have another professor, Dr. Sanjay Shah. It's also running very outstanding programs in air quality and animal housing system engineering. And he develops a applied research program as well as an extension program. I would encourage you also, if you have an interest in this area, I encourage you to check out his program as well. With that, thank you for your time, and hopefully we can see each other in the waiver labs soon, and hope you will choose to join us. Thank you and take care.